I will start my presentation on phyto-catalytic intensification of anaerobic processes during the agricultural wastewater treatment. First, I would like to present you some introductory slides about general situation with water resources and management in the Republic of Moldova, which I am representing here. The main water resources are two rivers, Nistru and Prut river. There are also about more than 3,500 small rivers, but they normally do not serve as sources of water. Also, we have a series of natural lakes and wells, and generally the most part of the water resources, including the drinking water resources, as can be seen from this slide, are used from the Nistru river and from the underground sources, and only about 1% is taken from the Prut river, which is a boundary river with Romania. The main issues for the water management is the poor condition of the water management in the Republic, relatively low quality of surface and underground waters, and the important fact is the surface waters are polluted by anthropogenic sources, including untreated agricultural waters. Our country is, seen on the map, is a small country between Romania and Ukraine with no access to the Black Sea, although it's not very far from it, and its economy is based mainly on the agricultural production. And the most part of agricultural production is wine and grapes. We discovered that aerobic treatment technologies of wastewaters are energy consuming, and they do not allow to reach the required treatment levels because of the high organic loads in the agricultural wastewaters. Therefore, anaerobic technology is much more acceptable for such treatments, including the benefits which can be obtained out of this treatment. First, we can receive the good quality water that can, in line with the irrigation standards, which is a precious product. And second, we can produce biogas as the source of the renewable energy. And last but not least, the sludge. The resulted sludge can be used as a fertilizer for agricultural fields, and in some cases, under the specific conditions, we can obtain the sludge as containing vitamin B12 that can be used as a cattle forage additive. In our university, State University of Moldova, together with the technical team from the Technical University of Moldova, we have initiated a series of interesting research of the biogas processes, because, as I have told you, the water treatment is one of the priorities in the country, and agricultural production is a priority as well. So, we have proposed a modified biogas technology for the treatment of agricultural wastewaters using the phyto-catalysts. We have called in such a way the additives of biologically active substances of different origin, of triterpene series and the others, which are added in very, very small quantities into the biochemical digestion process, and they completely modify the running of this process. The type new natural photocatalysts and an integrated bioreactor were developed for biogas processes, and this ensured the biogas production with a minimal contents in carbon dioxide and maximal contents in biomethane. Also, We have proposed the incorporated system of membrane recirculation, which made it possible to provide about 80% of the digestion of the biomass. If we consider the specific of methanogenic processes, we can see that at the methanogenic stage of biochemical reactions, the excessive reducer is eliminated, and the emission of mainly hydrogen and carbon first monoxide and then dioxide occurs in line with these reactions that are shown below. Hydrogen emission is catalyzed with two main enzymes, hydrogenase and specific co-hydrogenase, which act in common. And during the methane formation processes, the bacteria use the specific limited amounts of special substrates, among them acetate, carbon dioxide, formiate, methanol, methyl anilines, carbon monoxide, and others. To the right, you can see the photo of our laboratory set up at our university. A series of the technological and microbiological tests have been performed. I will not describe here the details of these tests, but the initial treated solution its contents and specifics is given here. We have used the post-distillery vinasse or post-distillery grains, which is hard, is very refractory. Refractory biomass, and it is not very easy to decompose its components. Also, we have tested the fermentation of the fallen leaves. This is a cellulose-containing raw material of the trees, and the data obtained have testified that under the proposed conditions, we can receive rather good treatment results. The microbiological studies have shown that the phytocatalysts affect the dehydrogenase activity, which reflects the reducing of the organic matter contains in the biomass. And the biologically active substances are practically immediately used by the microorganisms for their living activity. And thus, they adapt the microbial community in bioreactors to the new substrate, and the lag phase is reduced. The chromatograms has demonstrated that first during the digestion of the studied biomass, first the emission of hydrogen begins, then the process is shifted to the emission of carbon oxides, monoxide, and then dioxide, and in a few days later, the emission of the biomethane starts. This is a schematic of our laboratory setup. What is this? So, we have obtained rather interesting results, which I have mentioned right now. When we added such substances as squalene and betulinol, for example, into the digestion medium, we have received the sharp increase in the biogas release rate, as can be seen from the curves 2 and 3 on this picture. And the mixture of these two substances, squalene and betulinol, gives even better results. The formulas of these substances are given here. Betulinol was obtained from the cork of the birch tree, and squalene from the was extracted from the crushed seeds of amaranth. It's a flower, red flower. So we just made this work in common with specialists in organic chemistry from our department, and our students, which helped us to extract these substances. At the same time, I have no possibility to show you all the results, but a series of different substances have been tested, and rather interesting results were obtained. For example, some substances give us the higher rate of the processes, but the lower amount of the biomethane in the obtained mixture. And some substances, on the opposite, provide the emission of the biohydrogen instead of biomethane. So it's another process, very interesting, which gives us possibility to receive another fuel component. For example, I'm sorry, the graphs here is written in Russian, but the first is a control test. The second one is a tomatozid. Is a substance obtained from the tomato seeds, extracted from the tomato seeds, the second one column. Yes, you can see that it has a negative effect. It suppresses the emission of the biogas and biomethane and so on. So it's, the results are very different and rather interesting and rather amazing, because the analogs for such studies, practically there are no in the world. And we have generally received the use of phytocatalysts made us possible to significantly increase the biomethane yield and enhance its contents in biogas from 60–70% in average up to the about 90% and even higher, with a caloric value close to the caloric value of the natural gas. The overall efficiency of the methanogenic process was increased by our estimation by 1.5–2 times, and maybe even more. What is important, that these additives are to be applied in very, very small amounts, like I told you, in 10 to -5 to -7, maybe -3, it depends on the additive amounts. And besides, they are cheap. And the processes of their extraction are also not so expensive. And in some cases, we also tested the pure substances, crushed seeds, and some tests have demonstrated us that the results were very close to the pure substances, which means that we can avoid the extraction process and make the biogas production and wastewater treatment even cheaper. Another very interesting process which have been studied, maybe not as deeply as we wanted to do, but the effect has been discovered. If we introduce into the digested environment the salts of cobalt 3-valent, we are able to obtain in the components of the resulted sludge vitamin B12, about 90–95% of vitamin B12. I mean that almost all this sludge will be transformed into this substance. We really made this analysis of this sludge, and generally it can be recommended as a forage additive for the agricultural animals, for cattle, for poultry, but of course after the additional tests. Generally, such processes are known, but what we have proposed are new modified methods of preparing the cobalt complex compounds. They have been slightly modified. Also, another interesting issue which I would like to mention is the process of the cleaning, of purification of the obtained biogas. If you know, the biogas contains different series of admixture gases, among them CO2, H2S. So if we pass the resultant biogas through through the water containing the ammonia and diethanol amines, the admixture gases will be adsorbed in this water solution. So, so the biogas will be obtained practically in a pure form. And after that, the resulted liquid can be easily regenerated by heating up to 100 to 105 degrees centigrade. This process is also known from the course of inorganic chemistry, but its application to the biogas processes is not mentioned in the literature. So generally the proposed improved biogas technology improves the application of natural phytocatalysts, and as a result we received the treated water in line with irrigation requirements, sludge that can be used as fertilizer, or sludge with the contents of vitamin B12 as a cattle forage additive, and systems for the biogas purification from the admixture gases. This is our small team. Thank you so much. And also,
if you have any questions.
So what is the raw material used for the biogas production?
yes, like I told you, we started our research with post-distillery vinasse. And we also introduced the cattle manure. We have these experiments. We had a mixture of these two types of biomass. Then we took the poultry manure introduced. Also, the results were very good, maybe even better than in case of just post-vinasse. And also the dried leaves from trees. We also, this is cellulosic material, but we also received interesting results, and it is one of our proposed further areas of the research.
So, can I ask you,
Just a moment, because I don't hear anything in the streaming. Nobody's hearing. Just a second, you give a microphone.
hello, can I ask you something?
Sure.
Have you considered sustainability as any indicators about assessing the performance of wastewater treatment systems?
Yes, I will show you in the next presentation.
Okay.
Because we have compared, we have controlled process by the biogas composition, by COD, by BOD, and we have tested it on the pilot scales, on the semi-industrial scale,
yes.
And we have calculated the sustainability indicators
okay.
for this process. I will show you.
Okay,
Maybe
thank
very
you.
quickly, but they exist.
And they exist. Okay, thank you. Are they originated from a general systemic approach, or they are originated from specific indicators for specific site setting?
No. It's just general.
General, okay.
General.
Okay.
They were tested in two specific sites, in two wineries of Moldova, because we have wineries and they normally are situated near farms. So it was
yes.
Easy to take raw materials,
okay.
biomass for the experiments.
Okay, thank you a lot.
Thank you. I will take a bit more of your attention.
Yes, we're changing the order a little bit. The next speaker will come after. She had two talks. She'll combine them in time-wise, and then the next speaker will come.
So I would like to give you some information about the pilot scale testing of this new technology and modified bioreactor. I don't want to repeat it again, but of course the process of methane digestion or biomethanogenesis is known, for 4 centuries, but officially it was discovered in 1776 by Walter. And the biogas formation is a complex microbiological process, and normal biogas is a mixture of methane, CO2, H2S, and insignificant amounts of nitrogen, oxygen, hydrogen, and carbon monoxide. So the simplest biogas reactors, we've taken it from some articles, papers, they are interesting enough, but the objectives of our studies involve the developing of the biogas flexible approach to the biogas production, and to obtain the high yield of biomass and its methane, and simultaneous production of stabilized sludge containing vitamin B12. Here on the photo you can see our two professors on the biogas equipment, which was the biogas reactor was installed at the Bardar winery in the Republic of Moldova, using the available reservoirs which were not occupied by other processes. So this was easy and cheaper for us because to start the construction with new equipment, new reservoirs would not be possible under our conditions. So you can see these pilot biogas reactors where we have conducted our pilot scale studies. We have tested the introduction of our PHYTO-catalysts on a larger amounts, and we have received similar results. Also, we collaborated with the other agricultural farm at Fârladeni. It's in the central part of Moldova, who also have the winery and some agricultural production and a small poultry farm. So, as I told you, there was a good source of the feedstock. And we have, for example, we have tested two bioreactors. One of them was working for the production of the biohydrogen, and another one was working for the production of the biomethane. So if we have installed them in parallel, and and they were working in the autonomous way, under some different conditions. Because first our task was to produce biomethane, pure biomethane with no impurities, and on the base of the results which we obtained, it was very interesting to discover, to determine the condition of obtaining of pure hydrogen. It's another priority throughout the world. Here we described the main results achieved, and we have received that the biomass digestion time in bioreactor was about 1.5 to 2 times shorter compared to the control test without micro-additives, and made just a few and a half days. Biomethane contents in biogas received about 90% and above. The operation period was about 100 days during an year, especially during the summer season and autumn season, when there is a processing of grapes and the large amounts of wastewaters are formed. And here there are some figures, the electric power generated, heat energy generated, some income that was estimated from the generated electric and heat energy. And we have, according to our calculations, the repayment is expected to be in about 1.5 years. And ecological effect will be due to the prevention of the discharges of untreated wastewaters to the natural environment. And the amount of the sludge formed was about 22 tons, with a residual moisture contents of 72%. So that's the main figures, and that's shortly what I was going to tell you. If you have any questions.
Any questions, please? I'm not sure exactly what happens to the hydrogen. I understood that the biogas is used for producing electricity. What about the management of hydrogen?
The hydrogen is also a source of electricity. Yes, and it's very precious source. And there are, we studied the literature and the trends in the research, modern trends, and we have discovered that the production of hydrogen is one of the priorities throughout the world. So first, like I told you, we were not intending to obtain the hydrogen. But when we discovered using some additives, not tomato seeds, not these ones, but saponins and others, we discovered that they promote the increase in the hydrogen contents up to 60%, which is very high. And that's why we started another set of the experiments related to the production of hydrogen. And it's not finalized yet, that's why I didn't describe it yet, but the preliminary results are, I must say that they are interesting and promising.
And the best additive so far was...
you know, we have tested more than 30 additives, and among them up to 10 additives are very good for both processes. Okay, thank you. If you have any other questions, I'm here to respond.